Hey everyone, welcome back to our Conquering the JavaScript Interview series. Today we're going to be diving into a super interesting and super practical problem, the activity selection problem. Might be wondering, well, what's that all about? Well, something we all deal with, probably without even realizing it. Imagine we got a bunch of things to do. Could be meetings, classes, YouTube videos to watch in my playlist series, you name it. And you want to squeeze in as many as you can in your day without overlapping. Sounds like a regular Tuesday, am I right? Now, why is it important, especially if those of us gearing up for coding interviews? Because it's not just about managing a calendar, it's a classic problem in optimizing schedules or resources. It's about making smart choices quickly and efficiently. And let me tell you, interviewers love that kind of stuff. It tests your problem solving skills, your understanding of algorithms, and your ability to think on your feet. So if you got an interview coming up or you just love tackling cool problems, you're in the right place. As always, check the description down below for a link to our community membership for here at Covalence. For $25 a month, you get access to all of our courses, which are currently our front-end and back-end courses combined. That's our entire full-stack program. 300 plus hours of content, lectures, walkthroughs, and labs that will make you a stellar full stack CRUD developer. If you're interested, I have a Zero to Hero React course. So if you like my teaching style and you want to learn how to become an awesome React developer, I have that course, as well as any other courses, which I have 2 in the making, will be added to your community membership for no additional cost. You also get access to our Discord community where you can chat with me, other Covalence alumni, instructors, staff, whoever, or just other people on the coding journey in a supportive, fun environment. So if you're interested in that, check the description down below. Otherwise, let's get started. We're going to put this problem into perspective with something we've all been through. Picture this. You're in an office, your calendar is just bursting with meetings. You got a meeting at 10 a.m., a client call at 10:30, and let's not forget about the surprise catch-up. Your boss loves to spring on you, not looking at anybody at you, Covalence. You guys don't do that here. I don't get a lot of surprise meetings, thankfully. But the trick is to attend as many of these as possible. But hey, you can't be at 2 places at once unless you're Hermione Granger with that little spinny necklace thing, right? Which we're not going to discuss the details of that and the weird time messing around you can do with a necklace that lets you rewind time. Anyway, this is where our problem comes into play without stupid jokes aside. Think of your day as a big puzzle. Each meeting is a piece of that puzzle, and our job is to fit as many of those pieces together as we can without any overlapping, just like in Tetris, except with meetings instead of blocks. So we're going to imagine we got that calendar or timeline right in front of us. Cue visual aid. I don't have one. But just imagine you have a calendar or a timeline right in front of you. You've got like post-it notes that represent each meeting, and maybe it's actually scaled to its length of time. And your job is to basically align those meetings back to back across your timeline of the day and have as many post-it notes squeezed into your day as possible. Maximize that meeting time without double booking yourself. So no overlapping and no obviously going out after the end of the day. That's what we're looking to tackle with our code. How do we programmatically, that's the big question, choose the best meetings to attend? And again, this is making a lot of assumptions, assuming we want to put in as many as we can throughout the day and we don't actually care what they are or like externalities like travel time or someone being late. Those are way more advanced stuff. Again, this is meant for beginners, so we're dumbing it down. How do we maximize the number of meetings we can attend in a day with no overlap? That is the goal here, as we can see, right? We're going to ensure that's going to happen, and we're about to dive into the strategy to conquer this challenge, right? In the world of algorithms, we've got an approach called the greedy strategy. Take note of this because this is an important concept to understand, to solve this problem, to show off to your interviewers that you know what you're talking about. And no, it's not about hoarding cookies, even though I kind of like that idea. In our case, being greedy means we're always going to go for the activity that finishes the earliest. It's like eyeing the shortest line at the coffee shop so you can get your caffeine fix and still make it to work on time. So how does this work for our meeting dilemma? Well, it's about making the most of our time. When we choose a meeting that wraps up the soonest, we're freeing up our schedule to fit in more stuff later. It's like playing, again, a strategic game of time management Tetris. We're going to be picking the activity that ends earliest. We're not making random choices going, well, let's pick the longest one, start with that, and see what we can cram at the end. No, we're always going to pick the one with the shortest and just cram in as many as we possibly can. We're making smart, calculated decisions that open up our schedule for more activities. It's like having a personal assistant or a wizard at scheduling, right? It's nice. So why does this approach nail it every time? Well, imagine if you picked a longer meeting first. You might miss out on 2 shorter ones that could have fit into the same slot. Remember, the goal is as many meetings as possible with no overlap by end of day. So by going for the quick wins first, we're going to set up ourselves for, well, more wins, hence the term greedy approach. That's the beauty of it in a nutshell. Simple, effective, and dare I say, pretty clever. So keep on watching because we're about to finally start coding this out and putting this strategy into action. Again, you can find this code prompt in the CODEPEN. With the solution underneath it. You can always delete that and try following along with me, implement it yourself, get in the comments if you have alternate solutions. So we'll have several edge cases you can add to try and make it a bit more advanced, right? So the instructions are pretty clear. Like I said, we're going to have an array of arrays with start times and end times represented by index 0s and 1s for these positions in our sub arrays. We're going to maximize an algorithm that maximizes the number of activities with no overlap. We're going to do so by doing a greedy approach, and we're going to be able to discuss what that is to an interviewer if they're wondering what our solution is. And again, like as a human, you might be thinking, well, that doesn't make sense. But again, this is a programmatic approach. We have to make a decision, follow the strategy, and deal with edge cases later on, because that's what coding's about. It's about trade-offs, right? Very rarely will you ever code something that will solve the problem perfectly in every shape, way, and form. You're going to make a decision. It's going to handle most of your cases, like 90%. Then you're going to have 10% edge cases you have to deal with. I have some example activities with their expected outputs, so you'll be able to maximize this. So you can always copy and paste them to get going here. But like I said, let's go ahead and actually start coding this sucker out. We're going to roll up our sleeves and dive into this code. We have our function select activities. We're going to be passing in an input, which is our array. I'm going to call it activities for today's demo. That's what activities represents. It's an array of stuff. So we're going to tackle our activity selection with like I said, activities like our first one that run from 0 to 6, 3 to 4, 1 to 2. Remember, this is start time, comma, end time as these subarrays, what we're looking at here in terms of values. 8 to 9, lastly, 5 to 9. Quite a mix of events throughout the day, right? Well, let's see if we can cram them all in as effectively as possible. So the first thing we need to do, and the easiest thing to do, is to sort them, right? What we're going to be doing is sorting them by their finish times. Why? Because remember, we're being greedy from the earliest finish times, or for the earliest finish times. It's all about getting in and out as quickly as possible so we can pack in as many activities, our greedy solution. So we're first going to sort this by doing the following. Remember, sort is an in-place, mutative, so that means it's not going to return a new array to us. It's going to modify the input we pass in our activities array. A and B will represent each element of the array. Now remember, in our activities array, the dot sort A and B, let me go ahead and finish that right in the code block in case we need it like that, so y'all aren't staring at some broken syntax. For example, up in this input activity, remember, this would be A and B. It is not looking at the inner array elements as of yet, because again, all we care about are the end times, right? Because we're going for the shortest possible meetings and cramming them in as fast as possible. So A, B, right? And then I'll continue onwards down the way. So A and B represent a pair of values, which means I do not care about the start times. Like I said, if A is the first possible meeting in that input activities, which up there is 7 and 9 currently in view, we only care about the end time, which would be when does it end, aka 9. We're going to test the difference against which one is quicker. So we're going to say that right there is our comparison. That's our difference right there, right? Like I said, this is going to take the list of activities and it's going to sort through them, right? They're going to be neatly lined up N by N, and it's going to be time to start making our picks. It's going to sort it out, and that gives us an easy approach to our greedy solution. We can just go ahead and pick the first activity in this newly sorted activities array. Let's selected, past tense, activities equal a new array, because remember, we're going to be lining up meetings inside of here, and we need to be, the subarrays need to be crammed in there. So we're going to take our sorted array of activities with the shortest possible meeting being the first one, and let's just go ahead and pick it. If it's the shortest possible meeting, let's go ahead and put it into our array of selected activities. This also allows us to begin our loop at index 1 instead of 0, because clearly we're going to have to loop through something here eventually, even though I know this is a loop. It's not even technically, it is a loop. But our next loop, where we're actually going to be picking the shortest activity as well, it's going to make sure that we need to pick our activities after the first one because we've already done there. So we're going to say our last selected index. Because again, If the activity has an overlapping issue, it doesn't just mean that we're going to sort this and then just add all the activities in there by default. We need to compare them. We got to make sure that they don't overlap with each other. That was the other big part of the goal. Pick as many activities as we can that do not overlap. So we're going to have to keep track of which one we had last selected for comparison purposes. That's going to be very important. So that's going to be our last selected one, which is going to be the first activity possible, which is activity 0 in this case. Now, we're going to loop through this sucker, and like I said, because we pick our very first one by default after sorting, we can go ahead and start our loop at index 1 instead of index 0. We're going to be looping through so long as we have activities to compare to, and we're going to be looping through one index at a time. Nothing too particularly crazy here, right? Oh, and like always, I do this in all my videos, and yet I forgot here. We're going to take our selected activities, and we're going to make sure that we return them at the end, because remember, if you're at a whiteboard, if you're on a notepad, not in an IDE or a code editor, like if you're at an a very impromptu or not, again, not in a comfortable position writing code, then you want to make sure you have that keyword inside of there. Otherwise, tests will fail, interviewers will ding you points, etc., etc. So always make sure to have that return keyword there if this needs to return something, in which case, this is our selected activities. And as of right now, it ain't wrong. It's picked at least one activity, which should be the shortest one of the day. So like I'd said, we need to say something. We need to compare. Hey, is the next activity that we can put into our selected activities, will that overlap with the end time of our last one or not? That's what we have to compare here. That's what last selected index is going to allow us to do. So as we're looping through activities represented by I, we're going to say, hey, in the activities we've now sorted, at each activity we're looking at, remember, each one of these is representing a pair of numbers, like 7 and 9, for example, or up here, I think the very first activity of the day would be 1 and 2, which is how long it takes, right? So that's going to say, hey, look at the start time of this activity we're currently iterating over. If it is greater than or equal to our last selected, activity, which is represented by our last selected index, and its start time, I deleted parentheses, that's what happened. My bad, y'all. No, I moved it out of the parentheses. My apologies. Syntax is now fixed. So like I said, our currently iterated over activity, which is a pair of numbers, if its start time is greater than or equal to at the last selected activity, right, index, and its end time, that means it's not an overlap, which means we get to, you guessed it, push it into our possible selected activity. So we're going to say selected activities push the activity that is the next shortest one that doesn't overlap with our previous end time, so that there completes it. Then all we have to do is say, hey, we selected this activity, which means our last selected index is now the activity represented by the index of I. And as long as we keep iterating over that and make this comparison, we should be good to go. So like I said, it's a pretty simple breakdown. We define the function and activities as the array. This sort right here was a quick trick. It sorts it based on the finish time, hence the index 1s, if you weren't picking up on 0s are starts, 1s are ends, right? On the finish time of each activity, it's sorting by ascending order of the end times, the second element of each subarray. This initialized our eventual return value of what selected activities that satisfy the goals of this greedy algorithm, which is packing as many possibles with no overlaps. Because we have sorted activities, we have picked the first one because it's a good assumption that it's going to be the first one we can pick and pack into the day. That also is represented by last selected index. It keeps track of the index of the last activity we've added to selected activities, right? Then we're going to be looping through all the rest of the activities in the sorted activities array. Again, because we've already picked index 0, we can skip that iteration and start at index 1. Little micro optimizations like that can kind of show you off as a more competent developer than others in an interview process. If you know little things like that about skipping the first iteration when you can do so. I've had plenty of other algorithm and sorting videos where we talk about that and show those examples. Here's a great one as well, starting at index 1 instead of index 0. Then we have our important condition, right? This condition right here checks if the start time of the current activity, right there, is greater than or equal to the finish time of the last selected activity, represented by the highlighted code now, minus that parentheses right there. This condition ensures that there's no overlap in activities. That is the magic sauce that gets this done. This will add that selected activity should it satisfy that condition. This will update the last selected index to be I because it represents the last thing we added to the array, so that way our next comparison can check the end time of it back over here in the next loop iteration. And then from there, we simply return it because we've looped through all the activities and return selected activities, which should be the maximum number of non-overlapping values. So just like always, I'm going to go ahead and copy the first example here. We're going to do const activities is assign that value. I should really make my copy and paste a little bit better than this. This is annoying having to do it every time. We're going to do a comparative console log. We're going to have this one say outputs. And this will be that array of values. We'll have one before that that says input or test. And we're going to run select activities. And we're going to pass in the list of activities I have right above it. And if I save the file, we're going to go ahead and zoom this out a little bit. We're going to do out p so they have an equal length. There we go. So yeah, output and test are correct. We have now packed in the maximum number activities for the day with no overlap. This meeting ends at 2, this one starts at 3, and there you go. That is exactly what we expected to see, and this is a great use case on the greedy algorithms. This is how you tackle the activity selection problem. I've had a student get asked a similar question to this. So again, look for the patterns, look for the subarrays of start and end times and things like that, or if you have like coin selection problems for change and whatnot, that's also a great example of using a greedy algorithm, right? The greedy strategy in action, and it's we've seen it in action, and it's worked out quite beautifully for this particular activity. Selection algorithm, right? So that was a very Christopher Walken cadence, wasn't it? This activity selection problem. Let's take a step back and chat about this approach though, right? Because again, I think it's important that not only could you code this, but it would set you apart from others if you could define this as like, oh yeah, I chose a greedy strategy because it nails this classic problem, or coin counting for example. But is it always this awesome? And you can discuss and say, it's like using a Swiss Army knife. It's great for certain tasks, but maybe not the best choice for everything. So here's the thing about greedy algorithms. They're kind of like making the best decision in the heat of the moment. In our case, picking the earliest finishing activity was like choosing the quickest line at the supermarket or coffee shop is the example I think I used. It just made sense and worked out perfectly. But imagine a scenario where your choices now could limit your options later on, kind of like in a strategic game or even a more complex financial decision. Suddenly, that best decision right now approach may not seem so foolproof. In certain problems, particularly where the consequences of each choice affect future options, going greedy can lead us down a path that looks good at first, but ends up not being the best overall, right? So, don't let that dampen your spirits about the greedy strategy. I think it's a great approach to a lot of problems, especially if you recognize where it could be most beneficial. It's going to be another tool in your coding arsenal, and it's going to be key that when you see it and recognize it's a good fit, it'll solve the challenge and give you a great discussion you can have with your interviewer. Again, like being able to have a good, like especially if you're not taking like a take-home exam. Hell, if you're doing a take-home that has an algorithm series like this that you can answer, add comments about this stuff, right? Add comments that discuss this. Make your interviewers read that stuff. Go above and beyond, and it will set you apart from others, right? So I just want to give y'all a little food for thought in this particular discussion. So I'm not going to do the other examples and outputs because, well, you can use those for your own testing purposes. And I think I've rambled on long enough about this particular algorithm. And I wanted to give you all that primer on greedy strategy or greedy algorithms because they are something you'll see all the time, and it's important to know what they are and how to define them. And again, they're pros and cons. So we've reached the end of this little coding adventure. Pretty neat, right? Hope you all enjoyed it. And the fun doesn't stop here. If you want more videos like this, I have this entire playlist that I'll keep on adding more stuff to. Random projects that we build for fun across YouTube. I try to read the comments and respond to them if they don't get buried in, all the videos we put out. Comments like, YouTube's UI isn't the best. Trying to find all the comments. Like, I can find all the comments I haven't responded to, but there's so many. Sometimes they're hard to sift through. But nevertheless, comment down below. Make sure you like this video. Click our subscribe to channel button so you can see more videos that we put out all the time. If you have anything in particular you want to see, like I said, drop it down below and I'll see if I can get around to it or make a video on it, as I'm always hungry for more content. Although a lot of the times I'll prioritize anything my students ask me in Discord. But yeah, we've tackled this, we learned a neat strategy, and we've coded our way to a solution. So until next time, keep coding, keep exploring, and as always, stay awesome. Catch y'all in the next one.